Hello everyone, welcome to Hacker Heap. In this video, we will look into how KMP pattern search algorithm works. So KMP pattern search algorithm is basically used to find pattern in a given string. It helps you in searching. Let's say if you want to find ABC in a whole file, this is the actual algorithm that works to find the pattern. So let's look into naive brute force approach on how to do it. So in a naive brute force approach, the way we search if the pattern matches or not is so in the naive approach, we will start comparing the characters from the first element. So these two are matching. So we shift the indices of both of them. These two are matching, and here these two are matching, these two are matching, and B are matching, but C and D are not matching. So in a naive approach, what happens is we will start the search again, starting from the second index. So from here, and we will revert back to A. So we go through that again. A and B are not matching, so we will shift this index to C. C and A are not matching, and then it comes to A again, and A are matching. Now we will shift it to B and then to C, and again the index comes here, here, and again it fails here. So what happens here is again we were reverting back to this index. So this naive approach actually takes, let's say if the length of the string is m and length of the string is n, it would take order of m cross n in the worst case scenario. In this case, we would have to go back again and do it again until we find the exact pattern starting from that index, and we would return that index. So now let's look into how KMP pattern search algorithm works. So now in KMP algorithm, what it does is it will check if there is a prefix and suffix of the same type. Let me show you what I'm talking about. So now we have passed through this until we come here C and D where there is a mismatch. So this time it won't go back and start with index B. We don't want to backtrack to B and search from there. What it does is like, hey, is there a prefix and suffix of the same type? Yes, there is an AB and AB. So we start looking from C. In this case, we would start from here and we will compare C and C and then compare A and A, B and B, and again here it fails again. So again it will check if there is a prefix and suffix same. It's the same scenario again. We had a prefix and suffix of the same type. So it again starts with C here, compares C and C, which is good, and then compares A and A, which is good, B and B, which is good, and D, which is good, and it returns this particular index. So in this way, we are not backtracking to the initial index every time there is a mismatch of a character in both string and the pattern. So by doing this, we will achieve the worst case scenario with the time complexity of order of m plus n, m being the length of the string and n being the length of the pattern. So how do we achieve it? What we do is initially we will initialize an array for this pattern. For the given pattern ABC and ABD, what we do is we will take an array and we will initialize an array for storing the prefix and suffix indices. So let me show you what I'm talking about. So now we have an array. So initially A appeared only once, so there is no prefix, so it's 0. B appeared only once, there is no prefix, so it's 0. C appeared only once, it's 0. Now we see A again, so we need to know where A actually exists. So we will get this value, the index of A plus 1, or you can say at the first place. So this is 1, and we found B at index 1 or at the second place. So it's 2, and we didn't find D anywhere. So this is the first time we are seeing D, so it would be 0. So now, once we got the array, we have this string ABC, 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 ABD. Now what we do is, so we start with A, comparing A and A, which is good. So it goes to this index and compares B and B, which is good. Compares C and C, which is good. A and A again, which is good. B and B again, which is good. Now it comes to C, where it actually fails. C is not equal to D. So as we talked earlier, we will start comparing from C instead of going back to A and going back to B here. So how do we do that? So we do that by checking if there is any prefix. So we will look into this failed character index, and we will look into the previous index where it says 2. That means you can start comparing from index 2 as there is a prefix of AB that is equal to suffix. So we will start from 0. So we start comparing with 0 from here, and it looks good. Then we parse again, and here again it fails. Again we do the same thing. We will go back and start comparing with here. Since there is a prefix ab that which is equal to suffix ab, we populated this array before even starting the search. So now we had that. So now we compare C and C, which is good, A and A, which is good, B and B, which is good, and D and D. So we found the pattern in the string in the last indices. So once we found it, we would return the index of this one. But we were able to achieve this in order of m plus n times, as we are not going to A all the time. Since we found out there is a prefix already existing, we don't have to backtrack and go and look for it from the starting index. Similarly, we don't have to backtrack to the index, original index of the given string, and we can continue the search from the existing string. So in this way, we will be doing it in order of m plus n. I hope this helps and you understand the KMP pattern search algorithm and how it works. So now let's go ahead and write the code for it, and let's see how it works. Now I'm here on my Spring toolsuit. I have created this class KMP search. Let's go ahead. I'm going to write a main method here to initialize the class and all that stuff. And I'm initializing the strings and the pattern that we are supposed to match. We will take the same example that we looked earlier, ABC, 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 and ABD. Similarly, the pattern I'm going to take here is ABC, ABD. All right. So now I will initialize the class KMP search. KMP new KMP search. I'm just creating an object for this class to call the methods within the class. So what I will do is I will call the search string method. Don't worry, it's not there. We are going to write that out. str dot to char array, comma, pattern dot to char. Alrighty. So now we need to write this method, and let's capture the result as a Boolean result, which actually says if the pattern exists or not. So that's all we are going to do here, most of it. So now I will print the result. Pattern match, and it will say if it's true or false, plus result. Alrighty, what it says. Okay, cool. So now we need to write this function search string, which actually performs the KMP search. So this would be a Boolean, let me copy it, which takes two parameters, char str comma char pattern. So we got the two methods. Now, as we talked, we need to prepare the array where we store the prefix and suffix indices. So I will say that helper array, I will call this as a helper array, and prepare KMP array. So don't worry, we are going to write this function as well where we prepare the pattern. So now I will define the indices I and j, which we will use to traverse through the given string and the given pattern. So while I less than length and j less than pattern dot length, what I'm going to do is if str of I is equal to pattern of j, you know what we are supposed to do. We increase both the indices going to the next digit, going to the next character to compare them, I++ and j++. Else, if j not equal to 0, then what we do is j is equal to helper array of j minus 1, where we get the index, the value in the previous index. That means we know where the prefix ends. Else I++. So now once we are out of it, if j is equal to pattern dot length, that means we reached the end of the pattern, we would just return true. If we haven't reached it, we would return false. So this is the easy part. Now the tricky part is to prepare this function. Now let's go ahead and write that function. The prepare KMP function, which takes in the pattern, and now we will define the return array which we talked about, the helper array, and we'll define it with pattern dot length int index equal to 0. If we will start from index 1, I is equal to 1, I is less than pattern dot length. What we do is if pattern of I is equal to pattern of index, that means we found a prefix. Now what we do is helper array of I is equal to index plus 1. Now we increment the index, that means we are moving to the next value, and I++, which is good. If not, what we do is if index not equal to 0, then we would index is equal to helper array index minus 1. We will have the same value. Else helper array of I is equal to 0. If it is the first time, we are initializing with 0. So I++, and eventually we would return this helper array, which we will use it down. Oh, my bad, it's a for. Okay, looks good. So I have given ABC, ABC, ABD, and ABC, ABD. Now let's go ahead and run this. Run as Java application. So pattern match is true. Let me change this to E. Run as, so pattern match false because there is no pattern there. So now let me trace the code so that we had a clear idea about it. Now initially we are calling this search string, with a passed value ABC, 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 ABD, and the pattern value ABC, ABD. All right. Once we got it, the line number 25, we are actually calling the prepare KMP array, which returns the helper array, which we are going to construct there. Once we got the pattern here, so it started with index 0, started with index 0. So helper, if pattern a of I, pattern of I is equal to pattern of index, we are doing some stuff here. And in this case, a and b are not same, so we go here, and if index not equal to 0, we are doing it, but if index is equal to 0, we are initializing here, and we are incrementing the I. Now the I will be b, I will be 2, so my bad, I will be 2. Now we compare, which is not, and again it comes here not equal to 0, so index is still 0, we haven't modified the index. Now helper array of I is equal to 0, this would be 0, and now it comes to A. When it comes to A, we check pattern of I is equal to pattern of index. What we do is helper array of I is equal to index plus 1, which is 0 plus 1, which in this case would be 1. And we increased both the index and I. So now index would be 1 and I would be 0, 1, 2, 3, 4. Now again we check helper array of I is equal to pattern of I is equal to pattern of index. In this case, yes, B is equal to B. What we do is we do with 2, and when it comes to D, both are not equal, so it will be 0. So yeah, this is how we construct the helper array, and we are going to use this helper array in the search string method. I hope it's clear. Please do like and subscribe to the channel Hacker Heap. I will be explaining more problems and planning to do more fun stuff there. Thank you for watching, and please do subscribe to the channel and hit that thumbs up button. Actually, smash it.